Section 5. In this section, we're going to work with properties with logarithm and then write log expression as a sum or difference of log, and then write a log expression as a single log. And then the last one, we are going to learn how to evaluate log whose base is neither 10 nor natural e. So now let's look at the first topic, how to work with properties of logarithms. All right, there are two property, okay, or law you need to remember. Log a as the base of 1 equal to 0. Okay, this coming from the exponential law a to the 0th power equals 1. Okay, so they are inverse functions, right? So if you rewrite exponential law, and then we got this log. Okay, and similarly, a raised to the first power is always equals a. That's why log a as the base of a equals 1. Okay, so these two log property, they're both coming from exponential laws. And then other properties of logarithms, okay, those as a theorem, so you can use it directly without proof, okay. So here, the property is given, okay, m and a, they're both positive real numbers, and a is not equals 1, r is any real number, okay, and the number log a as base of m is the exponents to which a must be raised to obtain m. So that is a raised to this exponent, okay, which log a as the base of m equals m. Okay, that's the first property. And the second one, log a as the base of a raised to r power is equals r. All right. So how you remember these two? Because log, exponential, they're inverse functions, right? So a raised to this exponents, okay, which is the log a as base, is like a map from x to the y and then back to the x. That's why it goes with to the original, okay, m. Okay, or in other words, you can just think about a raised to the log a as the base. These two can cancel out. That's why it's only leave to the m. Okay, the second property, because log a as the base of a equals 1, okay, and then r, this exponents actually is equivalent to come outside as the coefficient. Okay, and then log a as the base of a equals 1, so r times 1, that's why equals r. All right, so now let's try some exercise, okay, to practice those properties. A, we use the property 1, okay, a raised to the log a as the base of m, that equals m, right? So this part cancel, right? So this is the same. 2 raised to log 2 as the base, these two cancel, that's why I only have a pi. Okay, B is a similar one, right? But use property 2, which is log a as the base, a raised to r power equals r. Right, so it's like these two canceled, and then that's why answer is just negative square root of 2. And then the C, that is apply property 2, log a as base a raised to r power equals r, right? Then that's the log e as the base of e, right? So these two cancel, that's why it just equals k times t. So log property, you know, when you're really familiar with those properties, and then it's very easy to do, okay? But it takes some time. You have to familiar with those properties, okay? So you have to really memorize those.